Hello, today we're going to begin talking about scatterplots. Okay, so let's first talk about a scatterplot. A scatterplot basically shows a relationship or association between two quantitative variables. That's very important. You guys should be comfortable knowing the difference between quantitative variables and categorical. So you're going to have two variables. One we usually call the x value, and one is the y value. When you get a problem and they talk about a scatterplot, you're going to assign one of the variables to be the x and one of the variables to be the y, or explanatory and response. Usually when you get problems, you can pretty much tell. And basically we use these x to predict the y's. So we use the x values to predict the y values. So sometimes we'll call the explanatory a predictor variable. Okay, some of you guys probably already worked with scatterplots in the past, but maybe not. So I'm going to show you how to do it by hand. So we came up with this problem. Examine the relationship between the amount of time studied and test scores for 10 AP statistics students. Here's the data listed below. This is for one test. This is for one exam. For example, this is student 1, this is student 2, etc. And that's where this comes in, on the same cases. So the cases in these classes, in this problem, is the 10 AP statistics students. We're measuring two variables on these 10 students. So I made this before. Okay, so we're dealing with quadrant 1 here. All the scatterplots generally go in quadrant 1. This is my x-axis and this is my y-axis, just like from algebra, x and y-axis. Okay, so when I put the numbers here, okay, we call that scaling. That's scaling. When I put the numbers there, so make sure you have to scale. You have to scale your axes. We also have to label them. Okay, in context, you can't put x variable. What are these? What are these numbers here? These numbers here, I gave the x to time, and I gave the y to the scores, because we're going to try to predict the scores with the time. Okay, and we're going to do that next chapter, but this is just to start. Okay, so this is going to be time, and put the units down, because time has many units. Okay, good. There's your time, and for here we'll go ahead and put the scores. Okay, scores in general are just points, so that'll be fine. So for student 1, it's just like graphing a coordinate from algebra, so this would be considered like 5 and 76. So I'm going to come over to 5 and I'm going to go up to 76. Somewhere right about here. Okay, and 154. 1096. Okay, so I'm going to pause the video and finish them, and then I'll be back. Okay, so if you notice, I made a few changes. I had to bring my time farther out because I had a 15 right here, and I was only up to 10, so I scaled that all the way to 15. And that's how you do it. That's how you do a scatterplot by hand. Okay, so usually with scatterplots, we do them on the calculator. So I'm going to show you how to do that on your 83s. Okay, so here's my calculator, and I've already put the numbers in the list. So I put all my x values in the list 1. So that's my list 1, and I put all my y's into list 2. Okay, so now we want to go to our stat plot, which is second y equals. So here's my stat plot. I have the first 2 on, so I want to go to number 2 and shut it off. I'm going to work in number 1. And you should be pretty comfortable with this. Go up to plot 1. Plot 1 is on. the scatter plot is this first one. So when you hit it, when you hit this, see it's blinking on it, I want to hit it, it's going to ask me for two lists. The X list and a Y list. Okay, so I have my list 1 and X1, my list 2 and my list 1 and X, my list 2 and Y, and you can pick anything you want. So let's see if this works. We want to do our zoom. Then we go ahead and get out. Now we want to zoom and 9. And there's our scatter plot. So it sort of looks like what I did. Okay. So that's how you do that. Let's just give you a quick overview. Now we're going to get into describing them. There's 3 things we always want to describe. That would be the direction. The second thing we want to talk about is the form. And the third thing we want to describe is the strength. Okay, and 1 and 3, I just happen to do this, we use R, which I'm going to talk about in the next video. But you could get it in, you could get a good look. You could get a good idea without using R, which is our correlation. I'm going to do a whole video about the idea behind this that you just want to watch. It'll be optional, and I'm going to use it. I'm going to do a whole video about everything about it that you do need to watch. Okay, so the direction, generally we have or 2 directions, which is positive direction or a negative direction, or it could be no direction. So a positive direction would be, it's as if the X values are increasing, the Y values also increase. Okay, just like that. If you notice, as the X values get bigger, the Y values also get bigger. Okay, and our negative is just the opposite. So whenever you're doing these, you have to think about that. You always say, okay, as X gets bigger, what's Y doing? When X gets bigger, what's Y doing? So here, as X gets bigger, Y is decreasing. Okay, so that would be a negative relationship. Okay, and neither, which I didn't put as an option, but neither, you could probably think, this is just a little common sense, neither is kind of like, as X gets bigger, Y is really not doing much. Y stays constant. It doesn't increase or decrease. Okay, so there's really no direction. Okay, that's pretty self-explanatory. You're going to be able to look at, you're going to be given a situation, assign the X value to one variable, the Y value to the other variable, and get an idea of what's going on about the direction. Okay, the next thing that's very important is the form. And the form is just it's basically, would this be considered curved or a line? Is this linear or curved? Or it could be quadratic, could be exponential, could be logarithmic. Okay, but generally this is the one that we want right here, this one. Okay, so if you look at these examples that I gave up here, that one and that one, those would be considered linear. Okay, so when you get something here and it does something like this, that's linear. Okay, you picture yourself drawing a line through it. Could you draw a line through this? Yeah. Curved, these could be considered curved too, but curved would kind of be something like this. This is more of a log. Okay, so that would be the log one. The exponential is the other way. So exponential kind of starts like this and starts, see how it's curved? Picture yourself drawing a line through it. you draw a line through and goes up, it's going to be curved. And quadratic is maybe as time goes on, the x goes on, x dips, but then it starts increasing. Okay, maybe your sales dropped after a certain minimum, starts going up. So that'd be your quadratic. Okay, and this is the one that we're interested in, this chapter and the next chapter. Strength is very important. The strength is very important. And like I said earlier, we're going to be using R, the correlation. Okay, correlation measures your strength and direction. There are going to be 2 whole videos on that. One will be optional, and the other one you have to watch, or you should watch. So the strength is pretty straightforward, not a lot to it. Okay, let's do this one. The strength measures kind of how much they're grouped together. Okay, how much they're grouped together. So I'll just write a few and see if you guys could take a guess and see which one's stronger. The stronger it is, the better prediction you'll get. Okay, so I'm making all the forms linear here. Okay, these are all dots. Okay. Alright, so the closer or more compact they are, the more strength it is. So this is very strong. Strong relationship. See how compact they are? They all follow there in that line. That means we're going to get a good prediction. We're going to use these x's to predict these y's. So whenever I put an x in from algebra class, we know that we could come over here, and that's going to be our prediction, which we'll learn later. Okay, which one do you think is the next? I'll name them. 1, 2, 3, 4. I already gave it away. 4 is the strongest. So which one do you think next is the most strongest? Okay, it is number 2. Number 2 is the next strongest. Okay, because these are compact, but they're not this nice. They're not as nice as number 4. So this would be strong. Okay. Okay, let's look at the next one. The next strength would be number 1 or 3. For the strongest, the next strong, we'll pick that one. So this would be considered moderate. Moderate strength. And the last one would be considered weak. Okay, so anytime you get anytime they say describe a scatter plot, okay, these are the 3 things that you have to describe, okay, in general. Later on we could use R for these 2, just to kind of write in your description, but for now we'll be fine by just describing these things, describing these scatter plots, describing the association with the direction, and all that. And I will do one example to show you from start to finish in one of the later videos. So thanks for watching and have a nice day or night.